Hello world, today we will be creating a real-time database to store data for our REST API running on Node server. The database would be created on MongoDB so that we can work with some real data rather than dummy data. Before we begin, let's get an overview about the main key points and topics that would help us during our coding part. We will look at these 4 topics that will help us to understand what is MongoDB and mongoose. They will also explain why we need external databases to store our data, and lastly we will look at how to connect our database and server through practical implementation. So let's begin. Firstly, what is MongoDB? MongoDB is a NoSQL database known for its high performance, scalability, and flexibility. Unlike traditional relational databases, MongoDB stores data in flexible, JSON-like documents, allowing for varied data structures. This makes it ideal for handling unstructured or semi-structured data, making development faster and more efficient. Its schema-less nature provides great adaptability, supporting rapid iteration and data model evolution. What is mongoose? No, we are not talking about the little cute creature on the right. Mongoose is an object data modeling library for MongoDB and NodeJS. It provides a straightforward, schema-based solution to model your application data. Mongoose offers built-in typecasting, validation, query building, and business logic hooks, making it easier to work with MongoDB. By defining schemas, developers can enforce data structure and relationships, ensuring consistency and reducing errors in the database operations. Using external databases to store data enhances scalability, security, and accessibility. Databases like MongoDB can handle large volumes of data efficiently, support concurrent user access, and offer robust data integrity features. They also enable centralized data management, making it easier to back up, secure, and query data. External databases free up server resources, improving application performance and allowing for more flexible and complex data operations. We will use Mongoose in order to establish connection between our REST API running on our Node server and the database present in MongoDB. Be sure to first create your server, for that you can refer to my previous video on how to create a server using Node and Express.js. Now, let's jump onto our coding part and implement a real-time database to store the data for our server on MongoDB using mongoose. Let's open our backend code and modify it so that we can store and retrieve data through our database. Firstly, we will install mongoose to handle connections and mongoose unique validator to ensure that the emails being entered by the users are unique. Now, create an instance of mongoose by importing mongoose. We will first create a connection with our database by using the connect method and moving the app.listen method in the then block of connect method. This way, our server will run only when the connection has been established with our database. For creating a database on MongoDB, you can use MongoDB Atlas or MongoDB Compass, whichever suits you. I will be using Compass for today. Open the Compass and click on Connect. From there, copy the connection string and paste it in the connect method of mongoose. After the port, you can specify the name by which you want your database to be created. I will use user login info for now. Let's now create our schema for the database, which will ensure atomic and only the specified data values are entered by the user. Import mongoose, mongoose unique validator and create a constant to store the schema for our database. Now instantiate a new object for our schema. Here we will provide the data type and other important fields that our input data should adhere to. For example, to make emails unique, we can set unique to true, and to make sure certain fields are required, we can set required to true also. We will now specify our unique validator plugin and export our model. While exporting, the name in the double quotes is automatically converted into lowercase with s at the end, and this becomes the name of the collection, which will use the schema defined above. Great, now it's time for us to modify our user routes.js file to implement the database logic. Firstly, let's modify the callback function for our signup route by making it an async function, as we are dealing with fetching requests from a database and updating it. This is an asynchronous process and should be handled by using async and await keywords. Now, we will check the condition if there already exists an email for a user signing up. If it does, we will stop the process and throw an error. The find_one method finds and returns one document that matches the given selection criteria. The catch block here will handle the error for a situation when the database is not being updated or an error occurred while contacting the database. Now, create a new user with the parameters provided by the user. In order to save changes to the database, we will implement another try-catch block as it is also an asynchronous process. The save method will save the changes to our database. The response of this callback function would be an object which will contain all the fields present in our database along with an ID. Now, let's fire up Postman, pass some values and see if changes are being reflected in our database. Be sure to run the server before doing so. As we can see, the database has been updated successfully. Let's move forward and update the callback function for the login route as well. Here also make the function async and check if there is data for the user with the email ID being provided by the user. Rest, all the code remains same. We can see this in action in Postman as well. Lastly, let's update the getUsers method. Here, we will make sure that the response does not include the passwords of the users. This will be an array as there can be multiple users, therefore we will use the map function to generate the outputs. Very well, now we have a working database, which can be updated by the server, and the server can also read values through it. In my next videos, I will try to integrate all this into one full MRN stack login page, as we have mostly covered the backend part. Until next time, happy coding!